Welcome back, everyone, to our third and last session for today at the BYK Live Event 2022. We're here at Altana headquarters in Germany, streaming live out to so many countries all over the world, to South America, North America, Africa, Europe, Asia. Wherever you are, especially the people late at night, thank you very much for staying awake with us and for all these great people here sharing their expertise with you and with us. We hope you enjoyed so far as much as we do. I forgot it a little before, we also have a poll function. So after every lecture, we would like to know what you think about the lectures themselves. There's a 5-star ranking, of course. 5 stars for very, very good, and 1 to 4 you can neglect easily. BYK is renowned for fluid additive products, but they're also pretty awesome at powder, cementitious products, marine protective, and also solid additives, paint that is supplied as powder without any solvent or water. So pay attention to the trailer voice. So there is something beyond liquids. What exactly and why they're so simple to use will now be presented to you by Kevin Spittka, who is Technical Service Marine and Protective Coatings, Judith Ewald, Head of Technical Service Powder Coatings, and Markus Möller, Head of Global Enduse Construction. The next session is called Break Free from Constraints of Liquid and Go Further with Hidden Champions Organoclades, solid additives and solid application powder coatings, and wetting and dispersing additives for high alkaline building materials. Welcome on stage, Kevin, and enjoy the show and the presentation.
Thanks, Mark. Once upon a time, there was a time when coatings could be either beautiful or functional. Both together was simply a fairy tale. And then, over 60 years ago, BYK made it possible. The first additives for coatings made by BYK. And with the help of BYK additives, attractive coatings could be made more durable, and durable coatings could be made more attractive. And since then, BYK additives help to defoam coatings, to stabilize pigments, to improve flow and gloss. Since then, BYK is leading in liquid additives. But we have never rested on the resounding success of these liquid products for liquid coatings. As you heard today, paints have changed in the last years due to different regulations which were updated, new binders were synthesized, new formulations were developed, and this resulted in high solid, solvent-free, powder and water-based coatings. And our innovations were not only related to liquid additives, not only liquid additives for conventional coatings, we are also innovative in solid additives. We made a virtue of necessity. You really can say that we have created a whole new world of additives, a world beyond liquids, a world where you can discover different things with different continents. Would you like to join us on a journey? There's one adventure or another. Are you interested in finding out what this world looks like? Get inspired into our world beyond liquids. Great pictures, right? This world is not just different. It is a great help for us and for the whole coatings industry. Because with solid products, we can protect our real world, the Earth, in a more sustainable way. Low waste, low VOC, CO2 neutrality, that are just a few of the buzzwords that are close to our hearts and our daily business. Let's now move on to the first details, to the first continent of our world beyond liquids. Organoclades as hidden champions among biological additives. Biological additives are a vital factor for quality for the whole lifetime of a coating. And I would like to give you more insight about this technique, these organoclades, hidden champions for BYK. It is only natural that people like to use liquid products in liquid coatings. But especially with biological additives, it's worth taking a look at the world beyond liquids. Organoclays in particular have unique properties that I would like to present here in more detail. For BYK and for me, they are really a hidden champion. It is not without reason that BYK spent more than 70 million euro in a production site in Gonzales in Texas. This production site manufactures exclusively organoclays. Why we did this immense investation? We see a huge demand for these products now and also in future. Why do we see this need? Let's look at some comparisons to other biological additives, to other technologies on the next slide, why we did this step. At first, I would like to compare a bisamate paste with an organoclay. You can see on the picture on the right side an organoclay powder, on the left side this crumbly bisamate paste. These bisamate pastes are usually 10 to 20% pre-activated paste in different volatile solvents. Organoclays, they're 100% solid powders, which means that no additional solvent is added when using them. Where can you still allow to add 80 to 90% of a solvent in your coating? And if you want to add larger amounts, you unavoidably add a lot of solvent in your coating. And all this material has to be stored beforehand. And this bisamate paste includes a lot of solvent, which means that the whole material is a dangerous good, which may be complicated to store in your warehouse. With organoclays, it's very easy because there are no dangerous goods. Organoclays are problem-free like a pigment or filler, a non-hazardous powder, easy to store. That's just the first comparison I would like to show. I would like to give you another one. Sure, there are other possibilities. There are other biological additives which are solid, for example, fumed silica. And here again the picture, a direct comparison between organoclay and fumed silica. Silica has one incredible problem because it has an incredibly low density. On the picture you see 10 grams of fumed silica compared to 10 grams of organoclay. And you see it's a huge difference. Is it a problem? With today's transportation costs, everybody reacts more sensitive on this topic. You can well imagine the difference in transportation costs if you transport 1 ton of fumed silica or 1 ton of organoclay. Not to mention the problem you may discover during incorporation of such a low density powder in your production. And there are also differences between organoclays. I would like to mention here Claytone MPZ especially. This product is produced in Gonzales and was developed 2 years ago. Claytone MPZ stands for maximum performance. And here I would like to give you a comparison between Claytone MPZ, the special maximum performance clay, and a standard conventional clay available in the market. Claytone MPZ is interesting because due to a special processing, we get nice benefits. No one wants to activate organoclays miserably long during paint production. And here, on this picture, you see a 2-pack polyurethane top coat formulation. And the organoclay has been dispersed together with the pigments and fillers at 15 minutes for 10 meter per second. As you can see on the left part of the picture, the competition product, you can see that the clay is not fully activated. So it was not enough shear force for full activation, and this will lead to severe stippling. But on the right side, the short incorporation time was sufficient enough for the complete activation of Claytone MPZ. So the ease of incorporation here leads to better optical appearance. Now we've talked a lot about site conditions, but what you really want to know is the actual performance when using a logical additive. So I would like to give here a comparison between a standard product and Claytone MPZ in a high solid marine protective coatings based on epoxy. Dosage is about 1.5% of organoclay calculated on component A. And you can see on the picture a drawdown by ZEC bar application. So we would like to differentiate here different ZEC resistance results. At the same dosage, same incorporation time, Clayton MPZ shows about 500 microns of wet film thickness. 500 microns wet film thickness compared to only 250 microns of wet film thickness. So really a maximum performance organoclay which boosts ZEC resistance. The next thought is often, okay, the ZEC resistance is twice as high, so probably the viscosity is also much higher, and it's impossible to be applied via airless gun. Therefore, I would like to give here some viscosity numbers measured by Anton par viscosimeter. On the left side, you see the viscosity, the mixture of component A and B, one time at very low shear rate, only 0.1 reciproc seconds, and at high shear rate, 1000 reciproc seconds. The samples are the same samples as on the slide before, where the difference was with higher ZEC resistance. And you can see that on the low shear viscosity, 0.1 reciproc seconds, there's approximately 3 times higher viscosity by using Clayton MPZ. But the interesting part is that the high shear viscosity, the viscosity 1000 reciproc seconds, so the shear range which is important for the airless application, is almost similar. So you can see on the right part of the picture the whole flow curve. There's a nice shear thinning effect by the use of the white product, by the use of Clayton MPZ. If we now take everything together and look at this continent of organoclays with some distance, then it's an important part of the world beyond liquids. With these hidden champions, we have safe products which are easy to use, easy to transport, and very pleasing to work with. And all this together with a really excellent performance. That's what I like about organoclays. So much as an insight for hidden champions organoclays. Since we haven't traveled that much in the last 2 years, Judith Ewald will take us on her personal journey into her world beyond liquids. So, Judith.
Thank you, Kevin. Kevin showed us the world of solid additives in a liquid application. I invite you to take one step further in this world beyond liquid. Solid additives in a solid application. My personal journey in this world beyond liquid started over 10 years ago, right at the start of my professional career. As an apprentice at a resin manufacturer, I learned to synthesize polyesters. I was challenged and fascinated at the same time. It is an art to create a transparent, functional solid. Certainly proud on this creation, it was still a chemical to me. Just when I stepped into the colorful world of paint, that changed. Using my polyester, my chemical in a paint application, it became so much more. It was that moment that I realized coatings were all around me. Powder coating on the fence of my parents' garden, powder coating on the shelf in the supermarket, powder coating on the railing of the stairs, as well in my professional life, powder coating on the bike I ride to work, powder coating in front of my workplace, powder coating on the window frames of my office. Powder coatings were all around me. So enchanted from this colorful world of paint, I continued my journey at university. I just wanted to explore more. But powder coatings always stayed in the back of my mind. Learning more about various application fields in coating systems, I realized powder coatings are special. Solid delivery form, heavy manufacturing process, highly durable systems. But there's one aspect that catches my personal interest. Powder coatings are sustainable. Facing the climate change, powder coatings can be one step to more sustainability in the paint industry. In this technology, we don't have any solvents, there's no VOCs, there's no biocides needed. 98% of the material can be used. The overspray can be recycled. We have a quick processing without the drying steps, and we have a high film build in just one spray. We create highly durable systems to protect what is valuable to us. Today at BYK, I support this sustainable application field with my everyday work. Let me inspire you on a journey into our BYK laboratory. You will get a glimpse at the evolution of a single powder coating, multiple steps of precise processing, a variety of chemicals with all different shapes and sizes, working in harmony together to create a protective shield. It starts with the meeting of coarse resin, heavy fillers, colorful dusty pigment, and powdery additives, creating a color swirl out of white and blue After mixing, they appear homogeneous to the eye. But after mixing, they appear homogeneous to the eye. But microscopic, they are still apart. Just mixing and melting in the extruder allows the ingredients to work with each other. After milling and sieving, finally, we achieve the finished powder coating, ready for application. The electrostatic spray pulls the powder particles from the spray gun to the workpiece and makes them stick. The rough coat is melted in the oven, creating a protective shield. Now, please follow me into our BYK laboratory. Supporting you in this technology means that we understand each step in the process by heart. As you witnessed in the video, we perform the whole manufacturing chain, from weighing in the ingredients to judging the cured panel and all significant steps in between. BYK products are based and designed on this knowledge. We support you with the whole selection of additives. Smooth surfaces with leveling additives, a high throughput with processing additives, anti-crater synergists and degassing aids for sensitive systems, protecting the surface with slip and scratch resistance, increasing durability with adhesion and edge coverage, and even allowing to apply on porous substrates without gassing additives. But now we take this support even one step further. For me, one of the biggest challenges in powder coating is that everything needs to be perfectly balanced right from the start. There's no adjustments possible in the finished powder coating. No tinting, no gloss correction. Everything needs to be perfectly balanced right from the start. The ingredients, the ratios, the processing parameters. But apart from all knowledge and all technology, I'm just human, and my results are not always as desired. Here, BYK 3938P comes into play. BYK 3938P is designed for post-addition into the finished powder coating. It is easily incorporated by mixing instead of extrusion and can be applied right after the incorporation. The matting effect of this additive is visible on the cured panel. There is no need to perform the whole manufacturing chain again to achieve my target gloss level. Post-adding the additive, incorporation by shaking, apply, ready. This saves time, energy, and waste. But let's have a closer look. BYK 3938P reduces the gloss depending on the dosage in a stable and predictable way. Here on the picture, you see the original system, starting with a gloss of 98 units at a 60 angle. On the picture, you see the reflection of a light bulb showcasing the gloss to the eye. Low dosages of BYK 3938P are used for a gloss reduction, dropping the gloss by just a few units. So if I have produced a powder coating a little too high in gloss, I can use the additive to bring the material back into specification. I can save this material. On the other hand, higher dosages of BYK 3938P provide me a real matting effect, dropping my gloss by 50 units or even more. This can be used if I have a demand of a customer, just having glossy system in stock, I use the additive, combine it, and can fulfill the demand. There is no need to wait for a new production lot to satisfy the customer request. Or I can even do a quick adjustment right at the line. You select your grade of matting, highly individually depending on your need and your demand. BYK 3938P is suitable in all resin systems, providing a universal usage. The universal usage also extends for all colors without interfering with the shade. A full shade black HAA system is matted as well as a purple hybrid system. A blue system with an effect pigment can be matted without losing the visibility of the pigment. Matting and sparkle effect are possible at the same time. BYK 3938P is even suitable in transparent systems. In a clear coat, BYK 3938P provides the matting without the loss of transparency. Here on the picture, you see a clear coat applied on a glass panel, and then the glass panel is placed over a contrast card. The white and black squares of the contrast card are distinct visible through the clear coat, showcasing the high transparency. Adding BYK 3938P, we don't lose this transparency. The white and black squares are still distinct visible while we have dropped the gloss. Even higher dosages of 3938P provide a high transparency, but reducing the gloss level. You select the grade of matting highly individually depending on your need and your demand. BYK 3938P is even suitable in challenging systems. In my experience, especially HAA systems are challenging to produce with the gloss that you desire. Even using the extrusion process, it's often not possible to reach the low gloss level that you're looking for. For example, in this HAA system with a gloss of 97, typically you would use a high dosage of wax to reduce the gloss. So you could use polypropylene or polyethylene. But you will just drop the gloss by a few units, having a gloss reduction but not a real matting effect. Another typical approach is to increase the filler loading in your formulation, dropping the gloss by 20 or 25 units. But you will also have an increased waviness on your surface. So your impression is a semi-matte finish, but with the increased waviness. This does not satisfy my design. With BYK 3938P, I am able to reduce the gloss from the 97 units down to just 27 units, providing a real matting effect and satisfy my design, even in the challenging system with a high efficiency. You select your grade of matting highly individually, depending on your need and your demand. I invite you to take one step further with BYK 3938P. Refuse the labeling, reduce your energy consumption in production, reuse a glossy system as matte design, recycle your out-of-specification material. Get inspired on this journey beyond. Now, let's move to the next continent on this journey with Markus.
Thank you, Judith, for this very interesting presentation and to lead into the next topic and to the next journey of interesting additives beyond liquids. Ladies and gentlemen, dear valued business partner, firstly, I would like to welcome you. Good evening, good afternoon, good morning. Historically, BYK's product portfolio has been mainly coatings-driven in the past. But looking to today's presentations and the recent activities, we offer solutions and additives beyond those applications, including additives for construction applications as well. We also consider the latest regulations and trends, and most important is the voice of our customers, your voice. While I'm standing here, you may have asked what I do have brought with me, and I would like to ask Mark to hand over a couple of items I took all the long way from Munich to Wesel. On the left-hand side, I have a few minerals, and on the right-hand side, a powder. And you may ask me, where is the link between both? Let me explain. When you look to those nice minerals, I'm pretty sure, even with no expertise in mineralogy, you may identify a few properties. This could be the gloss, the weight, the hardness, or the morphology. While with the powders, it looks like a powder. But without having a look to the TDS or to ask the inventor or test the product or even have a look on the label, you may not understand the secret behind this powder. It could be a binder, it could be an additive, it could be a filler. Mark, thank you. So, when I used to study mineralogy many years ago, working with additives, with solid binders, has been always a passion at that time. But I never thought about working for an additive specialty manufacturer and also talking about regulatory topics which have to be considered into our product development at that time. So regulatory topics, that played a minor role. Luckily, time and requirements have changed. So together with the other fantastic presentations my colleagues presented today, you could experience already a taste of how we as BYK have been developing our expertise beyond the development of liquid defoamers and additives towards powder additives, both for liquid and for powder coatings. So let's continue our journey beyond liquids with innovative, solid, wetting and dispersing additives. Colleagues of mine, and you know this as well, they have this expression, each construction is as good as its foundation. And that is true. But I would prefer to say, each solid additives formulation is as good as its solid additives package. So in order to take a step further on our journey towards a world beyond liquids, I invite you to have a look at current trends and challenges in terms of regulatory aspects and related new binder systems, and how we can, as BYK, support with new additives in the development of building material formulations and final products being fit for the future. I just want to name a few trends, or I wouldn't say trends, but challenges. One is well-known carbon dioxide reduction. We are also talking about new binder technologies, supplementary cementitious materials, or we have to full latest regulatory topics, and that includes also the biocide regulations, for instance. Let's start with the carbon dioxide reduction. You know that cement is the binder being used in dry mix construction formulations. But do you know that 8% of the carbon dioxide emission comes from the cement production? So it's mandatory that all the suppliers, manufacturers of cementitious binders, as well as you, for product development, have to look for alternatives. That could be supplementarious materials, fine particle size, recycled materials, and so on. And those changes have a tremendous impact and influence on the new additives, solid additives to be developed to overcome all those challenges. Let's also talk about biocide regulations. There are different ways to overcome the latest regulations. You can look for alternative biocides if they work, or you may increase the solid content, or the opportunity is to develop systems with higher alkalinity. Markus Vogel mentioned this in his presentation, silicate paints, for instance, or in our case, silica pasty products, construction products. Or the other way around is to develop more solid products, and those solid products require solid additives. There are some benefits. You have to ship less water across the ocean, the handling is easy, no biocides are required. So there are lots of benefits we have to consider and requirements to overcome those challenges. But it's not about all regulatory topics, it's also about technical criteria and requirements. And there are a lot of questions how to deal with those requirements. So let us talk about the desired technical criteria first and how we as BYK want to differentiate from the market standards. So when we had to look to our latest innovative additives developed for the construction additives portfolio, we decided to consider very important criteria. So one is the texture. So whenever you use alternative binder systems, which may require new wetting dispersing additives, you do not want to negatively influence the texture, the consistency. You want to improve the wetting properties, but negatively not lose or plastify even the formulation. So don't mix this up with a plasticizer, for instance. We do not want to plastify, we just want to enhance the setting without influencing negatively the texture, and meaning the particle-to-particle interaction. Another important topic is rheology. Rheology plays a minor role in construction additives. So we differentiate here between sag-controlled formulations and flowable formulations. And in both cases, we do not want negatively contribute with our additives to the rheology performance. We have seen market standards where you lose rheology, you lose suspension control in flowable systems and anti-sag in sag-controlled formulations. So important for the next stage of developed product is to overcome and improve those criteria. Another topic is robustness, meaning that you want to achieve good performance, efficient products over the entire application window, from the very first beginning up to the end of the entire application window. And we have seen that some of products, they negatively contribute, and either you have at the beginning or at the end performance, but not over the entire application window. Also compatibility with other additives, with plasticizers, with defoamers, with rheology modifiers have to be considered. So we want to stand for robustness with our products. Last but not least, performance balance. So how can we achieve good synergies with other additives? How can we improve, minimize side effects with the other additives? And that is what we have on our agenda. Looking to the watch, well, I talked a lot now, and it's now, I would say, showtime. And my team and I have decided, instead of showing very complex slides, to give some examples and to show some benefits of our additives in different applications. The first application is a base coat. A base coat applied in thick layers. And what we did is here, we compared the mixing behavior between a standard and our BYK 2290 as a wetting dispersing additive. So you see already the difference in the consistency, and more important, how does the wetting dispersing additive influence the rheology performance? And you remember what I said at the beginning, we do not want to negatively contribute. We do not want to lose suspension control and anti-sag control. And what you see in this video is exactly, you can improve the wetting, which is nice. You can plasticize, but you lose the control in anti-sag properties. And that is exactly what we do not want. With dispersing 2290, here clearly the difference. It's fantastic to see how we can improve or not negatively contribute to the anti-sag properties. So let's say we can improve the consistency and maintain the rheology and less shear thickening properties. The next example is a flowable formulation. It's a pre-mortar. We call it self-compacting concrete with a high density, good flow behavior, and low air content below 2%. And what you see is here the initial wetting properties achieved with dispersing, why it takes somehow longer with the standard wetting dispersing additive. Even when you add the fillers, you see how the consistency can change towards better mixing properties, workability properties. This is the one positive. On the other side, what happens with the flow properties? Here you see some air coming out much faster compared to the control, and this is based on the different rheology. It's not additional entrapped air. This is important to understand. The next test is the so-called test how the impact of a ceramic ball influences the rheology. Here is a control. You see the dilatant behavior, while with dispersing you can achieve a much better pseudo-plastic flow behavior without losing suspension control. So you can keep the liquid stable, but it is not dilatant compared to cornstarch, or you walk at the beach borderline, when you stamp on the sand it becomes hard. This is not the case. So you can imagine that with dispersing 2190 you can also improve pumpability in flowable formulations. All in all, we improve the texture and the rheology of flowable and sag-controlled formulation. But what's about the cement hydration? And you remember, there is a way, moving away from cementitious materials to ordinary Portland cements towards alternative binder systems. That could be recycled minerals, fine materials, and so on, with a large surface area, but sometimes they are not that fast in the cement hydration. So what you do not need and want to have is a wetting dispersing additive which negatively contributes to the cement hydration. So what we did is we test the wet sample in a so-called ultrasonic test equipment where we transmitted an ultrasonic wave through the sample, and then we checked the speed of the ultrasonic wave, which is an indicator of the setting. And what you can see here clearly is if you compare the control with our dispersing 2291, there is no negative contribution. The setting behavior is almost the same, but with the standard, market standard, there is a negatively contribution and also a retardation. So there are clearly benefits with the latest innovative additives here. Well, we are talking about wetting and dispersing additives, and you may ask, yeah, what's about wetting and dispersing? Can you show me? This is a test where we combined our different additives in a combination of microsilica and fly ash. And here you see how you can improve and fasten the wetting of those finer particle-sized materials. And I'm sure for the future developments, moving towards alternative binder systems, this is very important to achieve with the right dispersing additives we have recently developed. So all in all, improved wetting even in flowable systems can be arranged. So looking to all the presentations today, the first and the second session and the last one, we can clearly say yes, for all those challenges and requirements and the voice from you, we have tailor-made answers. And particularly for our wetting dispersing additives, that means that we can improve the mixing performance and fasten the mixing. We can maintain or even improve the rheology properties, achieve long-lasting flow properties and robustness in all those formulations, even with other additives in combination. And last but not least, and very important, there's no impact on the setting behavior at all. Clear message for everyone who has to change the binder systems in the future. So looking back to the development of BYK's additives portfolio over the past decades, we can certainly see how we have developed our solid additives over many years. Started with 2, and then we moved over to more than 70 products now. And this chart is not the end. So we continue with new developments, and we have already heard a lot today. I just want to name a few of the products already discussed. Judith mentioned BYK 3938. Kevin was talking about the Garamide 1958. I was talking about the DisperBYKs 229091 and so on. And there are many other products we have developed for solid applications or solid additives, even for liquid applications. So this is not a trip, this presentation. This is a journey. So I would like to take this opportunity to encourage you to contact the entire BYK team for further discussions and technical exchange. So at the end, looking back to our achievements and future developments, I can say definitely, yes, we can do beyond liquids. And Mark, having said this, I would say and hope to get all our audiences inspired beyond the world of liquids. Thank you.
You have definitely, because you did your job pretty well. Thank you very, very much. And you guys back home or in your offices did also a great job by asking so many questions. I've been to the back office and I've received so many printed documents here. And I'm going to ask them each by each to all of you. And I would like to ask you guys back here on stage again. Many thanks to you for presenting everything over here on stage. I would like to start with you, Kevin, with the first question. What do I have to pay attention to when incorporating organoclays?
So the working mechanism of an organoclay is it develops a three-dimensional network, a so-called house of cards. But when the clay is dry, then it's so in the direction that all the platelets are stacked. And it's important that all these clay platelets were properly dispersed, delaminated, and swelling. And yeah, there are two things to consider. One time is the polarity of the system. So when the polarity is very similar to the organoclay polarity, then it's very easy. But when the polarity is somewhat different, then it's important that you have efficient shear force dispersing so that the three-dimensional network can develop.
House of Cards already sounded good.
Yeah.
Judith, the next question to you. Can BYK 3938P also be processed through the extruder?
So actually, 3938P is just meant for post-addition. If you would process it through the extruder, you will lose some of the efficiency. So really add it to the finished powder coating, then you will get the whole effectiveness and the whole performance.
Thank you. Markus, how do the new solid alkaline stable wetting and dispersing additives influence the rheology properties of dry mix building material formulations?
Yeah, I think this is a very good and important question when we look to the new binder systems. And honestly, looking to our products, they exhibit extreme good pseudoplastic behavior rather than a dilatant behavior. So that will be resulting in improved workability properties together with our rheology modifiers and enhanced anti-sag properties. Compared to other conventional wetting dispersing additives or even plasticizers, water-reducing additives, we can maintain the rheology and even improve.
Thank you very much. Another question for Kevin, I guess. Do I always have to make a pre-gel, or can I add the clay along with the pigments and fillers?
So I know that, especially in the most parts in the coating here in Europe, I know that pre-gel is very, very common to use. And when it comes to very high glossy polyurethane top coats, I would also go for a pre-gel, because with pre-gels you can minimize the effect on gloss and you have a perfectly activated organoclay, which performs quite nice. But in most cases, when it comes to direct-to-metal coatings or primer, where gloss is not the most interesting part for you, then I would go for a grinding together with pigments and fillers, because if you have to grind anyhow, then there's no additional step, and that makes it really easy to use organoclays.
Thank you very much. Well, Judith, you won the lottery with the, I don't know, most questions of today. I'm just going to pick one. Is your laboratory located in Germany?
So actually our main lab is located in Germany, here at the headquarters in Wesel, but we also have colleagues in the US as well as in China who also have their own equipment and support the local demand there. So we work as a global team all together to support the customer.
Yes. Markus, are the WDs compatible with your hydroclay-based rheology modifiers OptiBend and OptiGel and BYK solid defoamers?
Yeah, this is a very valid point and a big advantage of our wetting dispersing additives. They are extremely compatible with our rheology modifiers, and you may know this, the OptiBend, OptiGel grades, they are based on so-called hydroclays. And we know from feedbacks that other market standards and plasticizers, for instance, they are not that compatible with our rheology modifiers. So here we can clearly say, and we have seen this in the videos as well, yes, they are, and that is a big plus.
So we're ahead of time. Let's say one more each. Is that okay for you guys?
Perfect. Okay. That's good.
Kevin, is temperature activation necessary?
So temperature activation is important for most rheological additives like bisamates or castor oil derivatives. By using organoclays, so there's no temperature activation necessary. So independent from the temperature, you have possibilities to fully activate and get the full performance. But under special circumstances, for example, production sites somewhere in the world where you're producing your coating lower than 10 degrees Celsius, then it might help to switch to another product group, the so-called Garamite. Garamite 1958, for example, outperformed then the standard clays in this terms of low temperature activation. But in general, there's no need for temperature activation of an organoclay.
Thank you very much. So this one sounds nice, Judith. Panels with BYK 3938P appear lighter in color. Why is that if the additive does not interfere with the color shade?
Yes. So the additive itself does not have any color. It also does not yellow under heat in the oven or even after storage. So the additive itself does not bring any color to the panel. But because it's a matting effect, it appears lighter to the eye. So the color that's received by the eye appears lighter. This is because the light that's getting on the surface, it's reflected in the spattered way instead of a direct way. So the impression of the lightness is just to the eye and not the real color shade.
Thank you very much. Now the last question for today for you, Markus. Conventional plasticizers show the tendency both to entrap some air and negatively contribute to the cement hydration. How do DisperBYK 2190, 2290, and 2291 influence such parameters?
Very good. Well, the focus during the product development was exactly on minimizing those negative side effects. This includes the entrapment of air. I wouldn't say not no, but less than compared to conventional additives. And that is also valid for the cement hydration. Very important to understand that with the DisperBYK grades, and we have seen this in the slide, we do not negatively at the typical amounts of 0.1, 0.2% of the loading level on total, we do not negatively contribute or impact the cement hydration.
Thank you very much, Markus, Judith, Kevin. Thanks for being with us today. You're dismissed for now.
Thank you.
Thank you very much.
Bye.